Next, we are going to look at the displacement reactions of chlorine, bromine and iodine, the properties and uses of chlorine and iodine, alkali metals flame tests, and halides with silver nitrate solution and their ionic equations. And finally, we are going to look at group 0 gases and their uses, considering helium, neon and argon.
So now we're going to look at our displacement reactions table. Here are our halogens: fluorine, chlorine, bromine and iodine. As we know, fluorine is the most reactive halogen, so it's able to displace chlorine, bromine and iodine. It won't displace itself, and none of the halogens will displace themselves. They can only displace elements that are below it. So chlorine is the second most reactive halogen. It can't displace fluorine that's above it on the periodic table, but it can't displace anything that's below it on the periodic table, which is bromine and iodine. Next is bromine. It won't displace anything that's above it. It will displace iodine though. And iodine is the least reactive halogen out of these four, and so it can't displace anything that's above it, and it can't also displace itself.
Now let's look at some of chlorine's uses. Chlorine is used as a disinfectant. It kills bacteria and is used in our drinking water and swimming pools. It can also be dissolved in sodium hydroxide solution, which is bleach. It forms sodium chlorate. Domestic bleach contains about 5% sodium chlorate. Chlorine dissolved in water forms chloric 1 acid, which is also bleach. Chlorine is used in the manufacture of many chemicals, including insecticides, CFCs, and the polymer PVC.
Some more uses of chlorine is when you react it with sodium to produce sodium chloride. And this is common table salt and is used greatly in the food industry. It is also mixed with grit and spread on roads to prevent roads freezing in cold conditions. Sodium chloride solution is used in a water softener to regenerate the ion exchange column. And electrolysis of sodium chloride solution is used to make chlorine gas, hydrogen gas, and sodium hydroxide.
Now we're going to look at the uses of iodine. So just like chlorine, iodine can be used as an antiseptic to kill bacteria, which is also safe to use on your hands. Iodine dissolved in alcohol, such as ethanol, was commonly used as an antiseptic. And lastly, potassium iodide is sometimes added to sodium chloride to prevent a lack of iodine in the diet.
Let's look at the flame tests. When any substance burns in oxygen, it's called a combustion reaction. The alkali metals can also be set alight and burned. These flame tests can be used to identify the presence of metal ions. Lithium gives off a red flame, and sodium gives off an orange-yellow flame. Potassium gives off a lilac flame when burnt, and calcium gives an orange-reddish flame, and finally barium gives a pale green flame. Potassium burns most vigorously, followed by sodium and then lithium, as you might expect.
Next, let's look at the silver nitrate test. Silver nitrate is used to test for the presence of chlorine, bromine, and iodine ions. Silver nitrate is added to water containing the halide, and silver halide is precipitated. The colour of the precipitate determines the halide. So let's look at chlorine. The ionic equation is as follows, and when silver chloride is formed, a white precipitate is seen. For bromide, the ionic equation looks like this. And the colour of the precipitate of silver bromide is cream. Iodide ions has this ionic equation. And when silver iodide is formed, it has a yellow precipitate. Cream and yellow can be very difficult to distinguish between.
Noble gases. Group 0 gases are inert, which means they are unreactive. Noble gases have 8 electrons in their outer shell, which means they are full and are not likely to gain, lose, or share them. This makes them more stable and therefore less reactive. The uses of noble gases include balloons or airships, in electric discharge tubes, inside light bulbs, or in welding to stop the hot metal oxidizing. That concludes our final video. Thank you very much for watching.